Hello, my name is Patrick Pryor, and this is my Physics 2212 Lab 1 charge tape. So the intro. So the goals for this experiment was to create two charged pieces of tape and analyze the reactions they have with each other. And then we're going to compare the observed model, which is the experiment that we're doing in person, with a computational model, and we're going to try to determine the charge on each piece of tape. And the results of this lab showed us that the charged tape had a positive charge of 3.49 e to the negative 8 coulombs. And because the charged tapes had a positive charge, we noticed that they repelled each other when they were brought close to each other. Important formulas for this is we need Coulomb's law, and this is just describing the net force between two charges. And we also need Newton's second law of motion, which is force is equal to mass times acceleration. So for our observed model, we had initial conditions with a length of 0.23 meters and a width of 0.15 meters. And then by taking the system as tape A and the surroundings as tape B with the initial conditions, we determined that the distance between the two tapes was 0.018 meters. And with our computational model, we were defining the electric field, and we calculated distance and incorporated the force of gravity. And by doing this and adding our initial conditions, we were able to determine that the charge on the tape was 3.49 e to the negative 8 coulombs, which we discussed earlier. And further with the computational model is then we had to model the tape as a line of charges instead of a point charge. And we found the magnitude of the force on individual charges. And that's what this code here was able to show. And the results of this showed that the magnitude of the electric force was 2.723 e to the negative 5, and the gravity was 9.134 e to the negative 5. So some possible errors could be taking too long to compare the tapes, causing loss of charge. Sometimes when I pulled them apart, it took me longer than I would have wanted, sometimes up to 10 seconds just to compare the charges. This could cause a loss of charge. And then forces on the surrounding affecting charge, such as my clothes. Sometimes I noticed that the tape would get too close to my clothes or attached to my clothes temporarily. And then some important assumptions was I had to ignore air resistance on the tape. And I also treated the tape as though it was a point charge, even though the tapes can be a little bit longer. And then we assumed that the charge was concentrated at the center of the long tape. And then I also assumed that each tape I may have had the same amount of charge, and that this charge was evenly distributed along the length of the tape. So what if the electrons had a positive charge and the protons had a negative charge? What would change about the observations is they really would not change, as the tapes would still be repelling each other. They would still have the same charge. Forces and interactions would remain the same, so it really wouldn't make a huge difference. And then, why is it important to handle the charged tapes as little as possible? Well, the reason is because things like loss of charge is just even when you barely touch a charged tape, some of the charge can transfer, like to my hand or other objects, because a lot of things such as our body act as conductors. This could result in the tape losing some of its charge and then reducing its effectiveness. And then unwanted interactions. If the tape might pick up a charge from other objects if it comes into contact with them, and then this could alter distribution of charge and then interfere with the results we get. So our results would maybe not be as accurate. But that's it. Thank you for watching.